morning all. This is Dr GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. In previous session, we have discussed about general bearing design. So in this session today, I would like to tell about rolling contact bearings. So as we know, the bearings are classified into two types. One is sliding contact bearings and another one is rolling contact bearings. In this session, the main objectives are about rolling contact bearings and the ball bearing and the roller bearings and the selection method for rolling contact bearings. So I hope at the end of this section, the viewers should be able to understand all these things. Coming to the rolling contact bearings, in rolling contact bearings, the contact between the bearing surface is rolling instead of sliding. So as we discussed in sliding contact bearings, the sliding takes place between two surfaces as in general bearing, but in this case the rolling takes place between the surfaces with the extra element, that is it may be ball or roller. So we will see in next slides how they classified into different types. So the ordinary sliding bearings starts from rest with practically metal to metal contact is possible. That's why in sliding contact bearings has a high coefficient of friction. That is the main disadvantage of the general bearings. But in this type of rolling contact bearings, the coefficient of friction is very less. So that's why these bearings are also called as anti-friction bearings. Why? Because these bearings are having low friction characteristics. And one more advantage is it can carry radial loads, thrust loads, and as well as a combination of thrust and radial loads. Whereas in sliding contact bearings, it can carry only radial loads. So it does not allow the combination of thrust and radial loads. In this, the rolling contact bearings are classified into ball bearings and roller bearings. So before going to that construction, here I want to share about rolling contact bearings advantages, uses. The mostly frequently used this type of bearings in machine tools like spindles, in automobile sectors for rear wheels and front axles, and in agriculture machineries also these type of bearings are used. The main bearing terminology is shown in figure. So here so you can see it is a combination of raceway, rolling element and case, lubricant and seal. So it gives the combination of all these parts gives a assembly that is known as bearing. The main construction parts of construction details of a typical ball bearing is shown in figure. It consists of four main parts. One is inner ring, and another one is outer ring, and third one is ball, and fourth one is ball retainer or case. The inner ring or inner race, so which is fixed on a shaft, and outer ring or outer race, which is fixed on a machine frame, and the rolling element, it may be ball or roller, they placed in a case. This is known as a case or retainer. So the retainer, so it separates the balls and as well as evenly spaced around the bearing. Here shown the detailed 3D diagram here, balls and case and race. Next, the rolling contact bearings are classified according to their shape and according to their load acting. So according to load acting, radial type bearings and thrust type bearings. So we will see, so what are they? The first one is deep groove ball bearing. So these type of bearings frequently used in machines and agriculture machines and spindles and etc. These deep groove ball bearings are used. In this type of bearings, the balls are placed in a case evenly. Here you can see the balls are arranged in a groove. In this type of deep groove ball bearing, the radius of ball is slightly less than the radii of curvature of these bear grooves. It can carry radial loads and axial loads. It gives less noise. It is used for light load applications, and it gives good performance in high speed applications. The second one is angular contact bearings. In this, the balls are arranged as in deep groove ball bearing, but the only difference is the angle or axis of the ball and the outer race axis makes some angle with the axis of the bearing. So that is the difference between the deep groove ball bearing and angular contact bearing. So that's why it can carry heavy loads. Next one is self-aligning bearings. In this type of bearing, the balls are arranged in 2 rows, and also it accommodates more balls when compared to deep groove and angular contact. See here, as shown in figure, the balls are arranged in 2 rows. it adjusts itself to misalignment of shaft. So it may be deflections of shaft, and due to vibrations of the shaft, some misalignments will occur in machine bearings. So, but all type of the angular misalignments it allows. Next one is cylindrical roller bearings. So in this here cylindrical, the shape of the rolling element is here cylindrical shape, but previously the rolling element shape is ball. And here one more thing, the whereas in a deep groove or angular contact bearings and self-aligning, the ball, the contact with the race is a point type contact, but here the line contact with the outer race. So that's why here somewhat high friction, high coefficient of friction will occur. In the previous case, deep groove and angular contact bearings does not give more high coefficient of friction. Next one is needle roller bearings. These type of bearings also similar to the cylindrical roller bearing, but only the difference is here the small size of cylindrical rollers are placed in a case, and the number of rollers also here more when compared to the cylindrical roller. So it accommodates more rollers. The needle roller main advantage is whenever the radial space is limited, there these needle type rollers bearings are used. Next one is tapered roller. In this, the rolling element shape is cylindrical, but the rollers are arranged on a periphery of the bearing in taper, some taper having this roller. So it means in such a way that the arrangement, the axis, the whole axis of the rollers intersect at one point with the bearing. So that point is called apex point. And the second classification, thrust type bearings. In this, the first type is thrust ball bearing in single direction, and second one is double direction, and third one angular contact, and fourth one cylindrical roller, needle roller, and a tapered roller. So here also the bearings classified same as the previous one, so that is the radial type bearings, but only the difference is the radial type bearings can carry radial loads as well as axial loads also. But in this case, in this type, thrust type of bearings, it allows only thrust type loads. The next one is the designation of ball bearings. So how to designate of a ball bearing? Here two standards are there. So one is the anti-friction bearing manufacturers association, so that is AFBMA. These standards are the ISO and the BIS also adopted. So according to this AFBMA roller bearing, the designation of bearing is like this. See here the designation is given 25BC03. So what is 25 here given shown? Here diameter of the bore, and BC is the type of bearing, and 03 is the width and diameter series. So like this, how to designate the ball bearing. Next one is series designation. So here the series are three types. One is light series, and medium series, and heavy series. So as shown in a figure, here the light series represented with 200, and medium is 300, and heavy is 400. So it means that according to that application, so divided into different type of series. The light the series application allows always light load applications only. For medium type, the medium load application, and heavy load duty applications, the 400 series most applicable. Here see, you can see the 6309 is one type of bearing designation. So it represents 6 is bearing type, and 3 is the series number. So it means the last 3 digits, the 300 series. 3 comes under medium, and 09 is the bore diameter. So how do we calculate the bore diameter? I will explain here. Take last 2 digits 09 and multiply with 5. So it gives 45 mm. So this is our bore diameter. Suppose if you select another bearing, that is 6407. In this, the 6 indicates bearing type, so that is ball bearing, and 4 indicates series, and last 2 digits indicates bore diameter. So what is the bore diameter here? 07 multiplied with 5, so 35 mm is our final bore diameter. So like this, how to give numbers for bearings. The next one is how to select a good bearing for a given application. Here I have framed this procedure. In this procedure, you should use design handbook. K. Mahadevan. I have taken some formulas from design data book or design handbook. The first step is calculate the radial loads and axial loads acting on the bearing. Which type of loads acting on a bearing, and determine the diameter of the shaft. And then second step is select the type of bearing for the given application. So for what purpose you are designing or you are selecting a bearing, so that is our application. So mention according to that given application, select one bearing. And then the third step is determine the x and y values. So what is x and y? X is the radial load factor, and capital Y is thrust load factor. These values also you have to take from design handbook. So how do you select this x and y? So I will explain. In data book, tabular form is available for calculating the x and y. In that, FA by FR or V multiply with less than or equal to E or greater than or equal to E column is there. You can verify your data books. Here the FA is axial load, and radial load, you can represent with W also, and here WR. This value should be less than or equal to E, or should be greater than or equal to E. So according to our value, you should take this X and Y. The step 4 is calculate the equivalent dynamic load. So this equation also I have taken from a design data book. W is equal to X into V into WR plus Y into WA. So here the X already you know, this is radial load factor, the V is rotational velocity factor, and WR is a radial load, and Y is a radial load factor, WA is axial load. By substituting those values in this equation, you can calculate equivalent dynamic load. After this step, make a decision about the expected bearing life. So that means you have to calculate the life of the bearing in a million revolutions, that is L. For calculating L, so in data book formula is available, you can refer design handbook. Step 6 is calculate the dynamic load capacity from the design data book equation. So that is C is equal to P multiplied with L to the power of 1 by 3. So this is for ball bearing. So for roller bearing also the formula is available in a data book. Here calculate dynamic load capacity. After this, you should verify this value with design data book tabular form value. This value should be less than the design data book value. So that means the dynamic load capacity for a selected bearing value should be higher than the calculated value. So then only your design is safe and your selected bearing number is correct. If not satisfied this value with the design data book value, then immediately go back to step 2. So that is select another bearing. So it means another series you can select, the 60, it may be 62 or 63 or 64. Take another bearing number, and according to that bearing take corresponding values, and again calculate all these values, and at step 6 again check this value, the calculated value with your the second selected bearing. So if satisfied, so no problem, that is your design is safe, and you can suggest or you can finalize the selected bearing, the 6309 or 6409, like that for different applications or given application you can finalize the safe bearing. If not satisfied, again not satisfied that value also, and go back to step 2 and again calculate all these values till satisfy the condition. So this is the design procedure or selection procedure of a ball bearing. So these are references I have taken. And in this session we have discussed about rolling contact bearings and types of ball bearings and types of roller bearings, and designation and selection procedure also we have studied. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.